Welcome, ladies and gentlemen. I'm Matt Biondi, as I think all of you know, and today I'm giving a presentation on debunked theories in the history of science. All right, so really quickly, because there was this thing on the paper tense in Nukem, I feel like I have to address this question. Yes, the universe is expanding. You can Google B modes found and figure that out. All right, so since the dawn of mankind, since we were but babes in the cradle of civilization, mankind has always sought to understand and question the world around them. However, we don't always necessarily get things right, which brings us to this. Okay, so I'm thinking of actually offering a short course next spring. It's not finalized yet. I have to do some talking with people. But look at this pretty graph. If you take my short course, you can understand these things a lot better than you will from just 20 short minutes of me talking at you. Okay, so on to today's topics. Today, we're going to discuss 3 different scientific theories that have all since been debunked. They are the Luminiferous Aether, Geocentricity, and Preformationism. Basically, from the graphic on the right here, you can see that basically any theory, any observation that you can make falls into one widespread category. When you experimentally verify or, well, support those things, they become what are called theories. And then when you verify them even more, they become laws, or basically as close to a law as we can get by still calling it a theory. So the first topic of the day is the luminiferous ether. Now I'm sure a lot of you are going, what the heck is that? So lumina, meaning light, and ferro, meaning to carry, both come from the Latin. And so you can infer that this means the light-carrying ether, or medium. And so this was the idea that up until then, all waves that had been observed had some sort of medium that they have to travel through. Water has to travel, of course, through water. Sound waves can travel through air, through liquid, or through solids. And so it makes sense then that light would have to travel through something as well, since it was proposed that light was a wave. But there's kind of a problem here. So if there's a luminiferous ether, if there's some sort of medium that light moves through, then either the Earth has to be some sort of special reference frame and we won't be able to detect any motion, or there should be some motion on Earth that we can detect. You can compare this with like a boat on water. If you turn through the water, or if the water is moving, you can tell that that motion is going on underneath of you. All right. So that brings us to this interesting model that is the toy boat model. This has been used actually in a lot of situations to help illuminate the ideas of the luminiferous ether. So if you have 2 boats that are each going on the same river, but they're going in different directions, perpendicular to one another. One of them is going with the current and the other is going perpendicular to it, and they both make round trips, then because the boat that is going perpendicular to the current has to push some of its speed against the current, you will observe that on its path it has a lower average velocity than the one that is simply going with the current and then directly away from the current. If there was no current, then these travel times would be exactly the same. If the water isn't moving, then it's just 2 times your path length over how fast you're going. So, disproving this theory. In 1887, 2 physicists named Michelson and Morley decided to test the idea of the luminiferous ether. So they set up something called an interferometer, which measures different speeds of light over the same path length in different directions. At left here, you can see the diagram that is basically the setup that they used. In the Michelson-Morley experiment, the path lengths were actually 11 meters, which was significant enough that they could detect, if there was one, could have detected a difference in the time. So basically, if the ether exists, the light from the first path and the light from the second path should reach the screen at different times. However, Michelson and Morley, to within a very impressive degree of precision for that time, did not observe such an effect, and so concluded, as close as you could at that time, that there was not a luminiferous ether. And this result was actually repeated again and again over the next several decades until we have modern precision, which basically says motion with respect to the ether is 0. So there's no ether. So our next theory is geocentricity. I'm sure you all know this one. So this is the idea that the Earth is at the center of the universe. Just let that sink in for a second. So the Earth is at the center, and then the sun and all of the planets revolve around it in what are called celestial spheres. Okay, so the evidence for this. It's actually surprisingly logical. So who would have had this theory? Well, there were a lot of observers of the night sky, from the ancient Egyptians to the ancient Greeks, and even up until the Middle Ages and the first scientific revolution, people held this theory to be true because of observations that they could make. What they could tell was that planets seemed to move throughout the night sky. Now, the theory about the night sky itself changed a lot throughout the centuries, but what was held constant was that the Earth was at the center and that the other things revolved around it. Now, it's kind of hard to see here, but in this third sphere is the sun, and Earth is the third planet from the sun. So their observations were very accurate in that they could tell the order of the objects in the night sky. They just couldn't tell that they weren't at the center. Continue, please. All right, so there is a problem here. So geocentricity predicted planetary motion, as we saw, very, very well, to within incredible precision. But it didn't account well for the retrograde motion of planets. Can you hit play? This is basically the idea or the observation that a planet moves backwards through the night sky instead of its believed forwards pattern. And we can see this here traced out as viewed from Earth, the planet Mars. This is the heliocentric model, which accounts for that motion. Geocentricity also couldn't account well for the varying brightness of objects in the night sky, but that was more due to eccentricity of their orbits rather than actual geocentrism. Okay, so the scientific revolution, one of actually my favorite periods in history. So, I'm sure most of you, if not all, have heard of Copernicus. He is the one who, not first, actually, heliocentric theories had been proposed since, I think, 274. The name is in the notes, if you can see it, Nelson. Starkus, I missed a C. In 247 BC was actually the first one to propose a heliocentric model. But they basically weren't accepted and still weren't accepted in the time of Copernicus until about 150 years after his death in the late 17th century. So Copernicus proposed this idea of the sun being at the center of the universe in his book De Revolutionibus in 1543. It actually took him some convincing from his friends to actually publish the work because he was afraid of not only scientific but also religious and cultural criticisms from his peers, which kept him from publishing for several years. Later on, Galileo, Kepler, and Newton would all go on to ameliorate his theory and to elucidate it a little better, make it more accurate. And they were aided greatly by the discovery of telescopes. So, the revolution, heliocentricity, and beyond. All right. So Copernican heliocentricity was able to describe retrograde motion, as you could see in that short video I showed before. It explained varying brightness to a degree, and it also still predicted planetary motion beautifully within the solar system. But there were still some problems, and these were what I was talking about before with Kepler and Newton and Galileo. These were the ideas that the planets, and also Einstein, didn't move in circular orbits, but actually elliptical ones. Another problem with the heliocentric theory was that, as you can see here, the perihelion and the aphelion of planetary orbits, specifically Mercury, seemed to move throughout the years. This is called the precession of its orbit. And this is explained by special relativity when it's, or rather general relativity, pardon me, that's wrong. When it was realized that the effects of gravity actually changed how Mercury orbited through time. And the other problem with Copernican heliocentricity is that it still predicted the sun to be the center of the universe, not just of our solar system. This was basically observationally disproved over the next several centuries. All right, this brings us to our last one, and this is a fun one. So this is the theory of preformationism, which is the idea that all biological life exists in these tiny little forms and just grow from there. Now, it's not entirely wrong, but it's wrong. So, please, look at this cute little picture of a baby. So babies grow during the gestation period of pregnancy, and then they grow more after birth, as is quite evident. So it made sense then that if you extrapolated back, that they would grow smaller and smaller over time. This wasn't really observable because microscopes hadn't really been made sufficiently powerful. And so it wasn't really something that they could see with their eyes. It was just an idea that made logical sense. This was when science was still in sort of a philosophical phase. This idea also comports with the idea of everything being pre-created by God. It made sense that God would make the organism and then it would grow from there. It also comports with Aristotelian forms, which is the idea that all objects have a set form. This is a philosophical idea dating back to ancient Greece, but as it was the late Renaissance, there was still a lot, or early Renaissance, pardon me, there was still a lot of adherence to ancient Greek philosophy. So, the problem with this. So in scientific terms, this theory is not irrefutable. Something that we recognize now in the scientific community is that in order for something to be considered a true theory, it has to be able to be refuted by evidence. That doesn't mean that it has to be false, just that someone has to be able to see something else. So since no method existed then that could possibly disprove this theory, it's kind of shady. This theory also concluded that either man or woman was not the creator, but the holder of life. So ovists and spermists were two groups of scientists in this era, each prescribing to one gender being the one who holds what's called the homunculus, which is that miniaturized form of life. Since gametes and chromosomes were undiscovered, basically the idea that organisms just were smaller and smaller as you went back in time was this idea of infinitely nested matryoshka dolls, which is kind of a fun image. Okay, so debunking this one was actually just a matter of time. When cell theory became commonly accepted in the late 1800s, people realized, and with the advent of microscopes being more powerful, people could see that in fact there were gametes and chromosomes that were what's the word I'm looking for? Contributing to the growth of humans in the womb. And another thing that helped to debunk this theory was Dalton's atomic theory of matter, which basically disproved the idea of the infinitely nesting matryoshka dolls. And that's it. Thank you guys for listening. All right, any questions? Yes.
You should really take Michelle's class.
Yeah?
You should really.
That's not a question, but okay.
It's a command.
Okay, cool.
Things in the form.
Yeah.
Oh. So the experiment you showed with the
Luminiferous Aether.
Ether. Why could it be that this ether just has no current?
So basically, even if the ether didn't have any current, so think about a boat on a lake, right?
Uh-huh.
If that lake is very still, but then you move your boat at a curved path through the lake, you create some sort of disturbance.
Okay.
So even if the ether itself wasn't moving, by the Earth's rotation, we would be able to detect some sort of wind.
I see. Okay.
You had something? Okay. Anyone else?